Hello. Let's try to write an exponential function from the given conditions. Okay. The problem before us is write an exponential function with a y-intercept of 5 and horizontal asymptote of y equals to 3. Okay. Now, for this kind of a problem, there could be more than one solution. Let us try to get one at least and then see the variation. Okay. In general, a transformation equation is y, you can say f of x is equals to a times b to the power of k x minus c plus d. So this is our general exponential function in transformed form, right? Here a is a vertical stretch. If a is positive and greater than 1, and its compression if it is less than 1 and greater than 0, and if it is negative, there is a reflection on the x-axis. For k, if k is positive greater than 1, then it's horizontally compressed by a factor of 1 over k. But if k is between 0 and 1, then it is horizontally stretched by a factor of 1 over k. For example, if it is half, then it is stretched vertically or horizontally by a factor of 2. If k is negative, then it's a reflection on the y-axis, right? It reflects horizontally on y-axis. C tells us horizontal translation. If c is positive, it moves right. Otherwise, c is negative. That means this becomes x plus something. It moves left by c units. D translates our function up and down. If it is positive, d units up, negative, d units down. Now here, what has happened is that we have a y-intercept of 5. That means if I plug in x equals to 0, I should get 5. And horizontal asymptote is y equals to 3. D also defines horizontal asymptote, right? Therefore, since the horizontal asymptote is y equals to 3, we say d equals to 3. So for us, d equals to 3, since horizontal asymptote is at y equals to 3. So we have d already with us. Now for our exponential function, let's consider our basic function 2 to the power of x, right? So let's consider basic function is 2 to the power of x, then b becomes 2, right? And we need y-intercept of 5. Anything to the power of 0 will give us 1 in normal case. So let's assume that there is no horizontal translation and there is only vertical translation. So we assume only vertical stretch or compression. Okay. So in that case, we can write our function f of x equals to a times 2 to the power of x plus 3. Does it make sense to you? So this will give us horizontal asymptote of 3, right? And we have assumed base function as 2. So we have 2 to the power of x times a. To get a y-intercept of 5, y-intercept is at x equals to 0. So as you know, anything to the power of 0 is just 1. To get 5, this number should be 2, right? So a should be 2, right? So we come up with 2 to the times. For clarity, I'm writing this 2 in the brackets, right? Plus 3. So this satisfies our condition, correct? Now, so this is one solution and it works very well for us. The other thing which we could do is, we could assume that there is no vertical stretch, but there is horizontal translation or horizontal stretch or compression. Okay. Now, so let's assume, so that is our first assumption, right? This time, let's assume that, let me do it in blue, that we have horizontal translation. and no vertical stretch or compression. Okay. Now in that case, a will be 1. Is that okay? Yes. In that case, our function f of x could be, so we are assuming a to be 1, and so we get 2 to the power of x minus c plus 3, right? Now, we want y-intercept of 5. That means if I write x as 0, so y-intercept is at x equals to 0, right? So always y-intercept means what? Y-intercept means x equals to 0, right? At that point, y is 5. So the coordinate here is 0 and 5. Is it okay? Y-intercept. Now, if x is 0 for us, then what should this value be so that we get 2 here? So 2 to the power of 1 is 2, so c should be minus 1. Is that okay? So if I put c as minus 1, I do get my job done, right? So I should write here 2 to the power of x plus 1 plus 3. Now here you can check what is f of 0, right? F of 0 will be 2 to the power of 0 plus 1, right? Plus 3, which is 2 to the power of 1 is 2, right? 2 plus 3 equals to 5. Is that okay? That means y-intercept is 5. Is that okay? So that is how you can make an alternate way of doing it, right? Here also, let's check the value. It's good to check our answer. So what is f of 0 here? F of 0 is 2 times 2 to the power of 0 plus 3. And anything to the power of 0 is always 1. So we get 2 plus 3, which is 5. Is that okay? And horizontal asymptote of 3, yes. As x is very, very small, correct? Very, very small. This will approach to 0, right? And you're left with 3. So in a way, for horizontal asymptote, it's just a reminder for you how we do take care of horizontal asymptote. And that is when x approaches in our exponential function minus infinity, then y approaches what? Now, anything to the power of very large negative value, it will be approaching 0, right? So the first term approaches 0 and we are left with 3. So y approaches 3 in this case, right? Here also, the first term is this, right? So in both the cases, we approach 3, correct? Therefore, it could be graphed like correct. Here, what we have is this point is 5 for us, and the line which it is approaching is at 3. Do you see that? In both the cases. So in one way, what we did is we stretched our function to meet the criteria, and in the other case, we horizontally translated our base function to 1 unit to the left to meet the criteria and 3 units up. Do you see that? So in either case, we can get our solution. So there, remember one thing, that there could be more than one solution for a given condition, and easy ways to assume that one thing is varying and the other thing is not varying. So that helps us to come to a good solution. Okay? Thank you. I hope you appreciate the method. Thank you.